This is a presentation I gave at the Geneva Softshake Conference in October 2013 about an experimental Evernote Pebble client I created. My name's Damien Mears. I work for Evernote, based just outside Geneva. Joined Evernote around 3 years ago. First of all, I worked on I created the Evernote client for Windows Phone. I then worked on Evernote Food for Android, and more recently I'm focused on Evernote and wearables. I created the Evernote client for the Samsung Galaxy Gear watch you can see in this New York Times advert. Although this presentation, that's a great watch, but this presentation is focused on another kind of great watch, which is the Pebble watch. So first of all, what is the Pebble watch? Where did it come from? Started last year with a Kickstarter, and the goal was to raise $100,000 on Kickstarter. They raised $10 million. So very, very successful Kickstarter. Some of the attributes of the watch. Well, first of all, it doesn't do much standalone. Basically, you can tell the time, and there's a few apps you can create that are standalone, but generally what you need is a watch. It kind of uses the watch as a relay. It works with both Android and iOS, and you install a Pebble management application from the App Store. So Pebble have released this application, and you install it on your phone, and you can use that to configure your watch and install applications on your watch. And it handles communications with your watch, which happens via Bluetooth. The Pebble watch has an e-paper display, which means it lasts for a long time, like around 7 days on one battery charge. It's backlit, so I'm kind of used to flicking my wrist to light up the watch if it's dark, and it obviously works in bright sunlight if it's because of the e-paper display. It's waterproof, which is really important for me. I dread having a shower and looking down and seeing what was a couple of $100 watch is now a couple $100 piece of shiny jewelry. But that's not the case with the Pebble watch. It really is waterproof. I have swum with it. It's not a problem. So that's one of the important features for me personally. It's got physical buttons, so you can't touch the screen. You can touch the screen, but it won't do anything. It doesn't have a touch screen. You can't swipe it and so on. Instead, it's got these physical buttons, one on the left and 3 on the right. In some ways, this is actually a good point for me. I can operate the watch without even looking at it. So if I'm driving and I want to pause my music, I know that 2 clicks on that center button on the right hand side will pause my music. So physical buttons, old, analog world, but in some ways it works well on a watch. If you're wondering what's on the left hand side there, on the bottom left hand side, that's how you charge the watch. There's a little charging thing that clips onto that magnetically and charges it up. Comes with a variety of different watch faces built in, but obviously you can download and install lots and lots of other kinds of weird and wonderful watch faces. And one of the kind of cool things is, as I'm driving along, if I get an incoming telephone call or a text message, I can glance at my watch, see who it is, and decide if I want to pull over and take care of it. So when I was preparing this presentation, my wife sent me a text message about the car not starting, and so I got that on my watch. So it's obviously, if you've got your phone out already, this is kind of pointless. But often you've got your phone in your pocket, and so you can decide whether or not to take out your phone and unlock it and so on, or you can just ignore the message. I didn't ignore this one. One of the big things for me personally is podcasts. I listen to a lot of podcasts, and these podcasts have adverts in them, and so I use the Pebble watch as a remote control for my phone, which is somewhere in my pocket or on a countertop somewhere, so I can just click and skip over the adverts, jump 30 seconds forward. Finally, one of the nice things for me is the Pebble watch doesn't have Runkeeper or any fitness app installed on it, but what it does have is a generic framework for fitness apps, and applications such as Runkeeper have included the functionality so that they notice that the watch is connected via Bluetooth and will automatically pump out information like how fast you're running and so on. So I don't need to start anything on my watch or do anything. I just run with the Runkeeper, and it displays this information on my watch, which is really nice. Obviously, I can click out of it if I don't want it, but it kind of lights up automatically when I need it, which I think is really nice. But what really drew me to the Pebble watch was the fact that you can install applications, that you can write applications and you can install them, up to 8 applications at a time, and applications are written in C. typically what you do, what I've done anyway, is written an application that runs on the watch written in C, and then a companion application that runs on my phone, and my watch application talks to my phone application. So let's have a quick demonstration of that. Before I go into the demonstration though, what I want to do is just tell you that this is based on 1.12 Pebble SDK released in June 2013. If you're watching this at some point in the future, there's a very, very good chance that there's a new SDK released, and some of the restrictions I'm talking about in this presentation may be lifted. Alright, so let's go and do a little demonstration of creating an application. What I'm going to do is create first of all an application that just says hello world, and then I'm going to make it talk to a watch application, and I'll create everything from scratch. So first of all, I've installed the Pebble SDK into my path here, so you can see it's actually under my home directory under Pebble dev. So there it is, Pebble dev, that's where the Pebble SDK is. So I've already installed the SDK. In order to create an application, what I do is use the Python script that they provide. Called create Pebble project, and the first parameter is the location of the Pebble SDK. And the second parameter is the name of the project I want to create. Now, because I'm creating this for the Softshake Conference in Geneva, I'm going to call my project Hello Softshake. Alright, so that's created a directory now called Hello Softshake and created a load of files in there. What I'm going to do now is just run the instructions it's told me to run. So the first one is this WAF configure. And what that does is set up a load of symbolic links to the Pebble SDK. And then I'm going to do the second command to build it. Oops. Alright, so that's built something, but we don't know what it's built and where it's built it to. So let's have a look at what it's building first of all. Is the contents of this Hello Softshake folder, or Hello Softshake file I should say, and it's built it to this PBW file. So that's the output of the build. So that's the Pebble Watch output file. Alright, so let's take a look at the source file first. Let's open it from scratch because I don't think I named it the same thing as before. Hello Softshake source. Okay, so this is the generated kind of template framework application that was created when I ran that Python script. First thing it has is this unique ID. So this is a UUID that uniquely identifies the application that was generated for me. It's got some template information here, some kind of metadata. So let's call it Softshake. And the first thing that gets called when the application starts is this main. What this main does is set up some initialization information, some handlers. So basically I'm saying here, when the application starts up, I want you to call hello init, or handle init, sorry, which is defined up here. And then the application, my application hands over control to the Pebble Watch. At some point in the future, the Pebble, will start up my application, launch my application, and it'll call back into my code here. And what my code does here is initialize a window and pushes it to the top of the application. So as you'd navigate down inside an application, perhaps clicking on menu items, new windows would be pushed onto the stack of windows, and then they'd be popped off as you navigated back up. But this application doesn't do anything really that you'll be able to see. It just pops a blank window or pushes a blank window to the top of the screen. What I'm going to do is put some text on there. So I'll define a text layer variable. So a text layer is basically something into which you can draw text. I'm going to initialize it. I'm going to pass in the address of my text layer, and I'm going to say how big I want it to be. So I want it to start at 100 or 1010, and I want it to be 100 times 100 wide. So I've initialized my text layer. Now I want to say what I want to actually display on it. So I'm going to say text layer set text, and I'll pass in again the address of my text layer, and I'll, in time on a tradition, say hello world. And then finally, I've initialized my text layer, I've set its text, I actually want to pop it or push it onto the window there. So the way I do that is by saying layer add child. I'm going to pass in the root layer that's associated with my window. And I'm going to pass in the text layer. Now this actually requires a pointer to a layer, so there we go. So layers are essentially objects that are displayed on the screen, and they're displayed as you'd expect. You know, if I put one on top of another, it includes the one underneath. And there's all kinds of different layers for buttons on the right hand side of the screen, or bitmaps. There's all kinds of different layers that come with the SDK. Alright, so now I have my my simple application. Let's save that. Okay, and now I'm going to go back and build it. So I'll do the same build. Alright, it's built. Now somehow I have to get this over to my watch, and the way I get this over to my watch is via my phone. I have my phone, an Android phone attached. So let's look and see what devices are attached. And there we go, there's my Android device. What I'm going to do now is push the PBW file that I just created onto the SD card of my Android device. So this is the new application. Alright, that's zoomed over. It's now sitting on the SD card of my Android phone. Alright, so let's look at my Android phone. Okay, this is my Android device, and I browsed to the SD card. Let's refresh the SD card so you can see what's there. Alright, and there we have my Hello Softshake PBW file. So I'm going to click on that, tap on that, and that's launched the Pebble app, which is now sending it to my phone. So to my watch. So let's get my watch now. Go down to Softshake, and there we go, there's my Hello Softshake app that I just created. Okay, let's take this a step further now. Switch off my iPhone for now. So I want to make my Pebble, I want to send something from a Java application, from an Android application that runs on my phone to my watch. So I'm going to launch IntelliJ now to create a new Android application. Let's create a new project. Okay, and we're going to call it Softshake Client. It's an Android application. Okay, so this is just a standard Android application. Let's first of all update the user interface to put a text box on it so that you can enter some text, and then a button so that you can send the text over to the watch. Alright, so let's pop on a let's pop on a text box, and we'll pop on a button. Alright, so the text box's ID is edit text, and the button's ID is, you guessed it, button. So that's how I'm going to refer to those in my source file. So let's go to the source that was generated for me. Alright, so I'm going to grab hold of that button, and when it's clicked, send the text that's in the text box to the Pebble watch. So let's get to the button first. Alright, I've got hold of the button. Now button.set. So when the button is clicked, this code is called. Alright, so let's get the edit text now. So grab hold of the text. That's the edit text. Okay, and then I'm going to grab the string from that text box. Alright, now if you've done any kind of client programming in the past, you'll know that the last thing you want to do is do I/O on the UI thread. So this onClick is being called on the UI thread, so I don't want to do that, so I'm going to create a new thread. Make sure we start the thread. So here I want to actually send the text here over to the Pebble watch. How do I do that? Well, I'm going to need to use a Pebble SDK function to do that. And so I'm going to go to navigate to the Pebble SDK, and we'll see that under the Pebble SDK we have so this Android directory, and underneath that we have this source, and we have basically the Android the source code for the Pebble Java SDK or Android SDK. So I'm going to copy that, and I'm going to go to my IntelliJ and paste that in. So that's given me access to the Pebble SDK now from my app. And so to send the text to the watch, I need to call pebblekit send data to Pebble. The context, so that's going to be the activity. The next thing is the UUID of the Pebble watch app, and the last thing is a dictionary here of data. Alright, so let's look at those. So first of all, the app ID. So that's it's going to be what in Java is a UUID. I'm going to say from string, I'm going to pass in the UUID. This is a little bit messy, but what essentially you have to do is grab the UUID from Pebble generated code, but it's in the wrong format. So what I've done here is just replaced in this selection. What I do is replace first of all the 0x's with nothing. Alright, now I replace the commas with nothing, and I replace the spaces with nothing. Okay, and then 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, now that's in a format that Java knows about. And then so that's the ID set up. What about the data? So in order to pass the data over, what I need to do is create myself a Pebble dictionary. So a Pebble dictionary, so data that's sent between, or what you send between the Android device and the watch is a dictionary of name value pairs. So this is a Pebble dictionary. Obviously it's called data. Alright, and then what you put into there is like I said, name value pair. In this case here I'm going to add a string because what I've got is text, but you can put in bytes, a byte array, or short, or all kinds of stuff. So the key is a number. It can be any kind of number. Normally you define a constant. I'm just going to swipe across my keyboard and say it's 456, and the text is there. So that number is basically, as long as you agree between your Android code and your watch code, so long as what you put into the dictionary is the same value as what you get out, it doesn't really matter. You can just define 0, 1, 2, 3, 4, 5 for your keys. I've just chosen 4, 5, 6 here. Okay, so that's the Java code. I'm just going to make that to make sure everything's okay. How do I extend my Pebble watch code, my C code, in order to receive this message that's being sent from the Java side of things, from the Android side of things? So let's go back to the C code here. First thing I need to do is tell the Pebble watch how big the buffers are that I want to send over or between the watch and the phone. So this is just kind of boilerplate stuff. So my inbound buffer is going to be, oops, sorry, it's not buffer sizes next. My inbound is going to be 64 bytes, and my outbound, although I'm not actually sending anything from the watch in this example, same 64 bytes. Okay, I'm going to save that, and out of an abundance of caution, I'll just build it, make sure I've not made any silly mistakes yet. Nope, not yet. Still to come. Okay, so now I've set up my buffer sizes. I want to say what function I want to have called when the message is received. So in order to do that, first of all, I'm going to define a callback structure. Okay, and then I'm going to initialize that callback structure in when the app gets initialized. Okay, and it's a very simple structure, at least what I'm putting in there is pretty straightforward. So I want my in received to be, and then this is the function, so let's call it my message handler. Okay, and there's a kind of context that's passed between with each call, which can be anything you want it to be. I just don't want it to be anything, so I'm going to say null. So in here you could also put what's called if the send or receive fails, or what's called in all kinds of different situations. In here I'm just saying I want it, or the only thing I want is the function that's called when the watch receives a message. So then that's called my message handler, which I still need to define up here. So this is the code that's actually going to be called when the message is received. And I'm sending a dictionary, so as you'd expect, what I receive is the Pebble watch equivalent of that dictionary that I sent over. And this is the context that I defined below here, which again is going to be null. I'm not using it. So the first thing I'm going to do is just vibrate the watch, so that even if my output to the screen is screwed up for some reason, maybe if I make a mistake there, I'll be able to know that the message was received. So what you receive from the watch, from the phone, sorry, like I said, is this dictionary. I'm going to grab a name value pair out, which is a tuple. So I'm going to find that from the dictionary, and the dictionary is this received dictionary that's passed in, and the key is the same thing as I passed in, or I set defined here. So that's 456. So if as long as those are the same, it doesn't really matter. So let's go to 456. That brings back the tuple, which is a name value pair. And now I'm going to set the text, just as I did before, but with the value that I've received. Text layer, and now the tuple, I go to the value, which is a union. So there you find your byte array and all kinds of things, but in my case it's the C string that I want from that union, because I'm passing in a string. Alright, and I'm going to save that again. Let's compile that again and see what silly mistakes I made. Okay, none that are obvious. Alright, so let's go now. What we're going to do now is deploy this just as before. So I'm going to push that over to my watch. Start up the camera now. So I pushed it to my phone there, I should say, and then from my phone I'm going to push it to my watch. Alright, now we start up the camera. Make sure the camera is in the right orientation. Alright, deploy it, let's refresh and deploy. Alright, now let's start the watch app up. Alright, now let's launch the Android code. And if I enter some text here now, it's got to be typed correctly. There we go, hello, and press the new button. We can see the phone vibrated there, well, the watch vibrated. And its text is being sent over. So when I first looked at the generated code there, I was a little bit shocked because I didn't recognize the C code. At least there were a lot of things I didn't recognize in it. And I realized that although I'd stopped using C in the early 1990s, the world hadn't, and a new version of C had appeared, C99. So things like the highlighted code here with the initialization of the structure in line is just something new that I had to get my head around. The second shock I had was that with the Pebble there's no malloc and free, and if you're used to programming in C then you'll remember that that's a big part of C programming, and C++ programming was allocating memory and freeing it, and obviously often you forgot to free it and you ran out of memory. With the Pebble it's not like that. Essentially you have to allocate everything in advance, so everything's declared globally or on the stack. My third and final shock was that although there is an infrastructure for passing messages between the watch and the phone, the maximum message size is 100 bytes or so. So in today's world we're used to using JSON buffers and so on. It's not really going to work when you've only got 120 bytes, so I moved to using binary buffers. So my dream was to create an Evernote client on the Pebble watch. Before I go into that though, just a quick word about what Evernote is. Evernote's about making you more intelligent, about making you smarter. And our core application, the original application, is Evernote. Now, Evernote's a service. It synchronizes notes across lots of different devices, whether it's an iPhone or Android and so on. This is the Windows client, and the way I use Evernote is that I have just 2 or 3 notebooks. On the top left hand side there you can see my notebook names. So each note in Evernote can go into one and only one notebook. So I just have, I have book PDFs with big notes, personal where I put pretty much everything, and unfiled where I put stuff that I still need to file. Even though I don't only have a few notebooks, I have a lot of tags. Tags are like labels in Gmail. You can tag a note with as many different tags as you want to. So although a note can only be in one and only one notebook, it can be in as many, you can tag it with as many tags as you want to. So you might tag a note with expenses and taxes and so on, and tags can be ordered hierarchically. So this is how I use Evernote. I use lots of tags. There's no one true way, this is just how I use it. When my kids come home from school with a piece of paper, I'll scan it and put it into Evernote. I scan receipts, put them into Evernote. If I'm browsing the web and I come across something that looks interesting, I'll click on the little elephant icon for the Evernote plugin in Chrome, and it will clip it and store it in Evernote. Buying or trying to make lunch for my kid for school, and I find out I'm out of creme fraiche. I know that in 2 hours time when I'm sitting in front of the supermarket aisle with all the dairy products, I have no idea what I'm supposed to buy. Take a quick photo, put it into Evernote, and it'll be synced to my Android device, and I'll be able to remember. I also create notes by hand, so my IP addresses are associated with various different devices at home. This is a note I created by hand. Every account in Evernote has an email address associated with it, like a secret email address, and everything emailed to that email address gets put into that Evernote account. So when I get any email that's interesting, I'll forward it to Evernote. Sitting in front of Lake Geneva, beautiful day, wearing my Google Glass, I say, okay Glass, take a photo, okay Glass, share to Evernote. If my wife writes instructions on what to make for lunch, take a photo of it, put it into Evernote, and then I can search it later, because Evernote finds all the text in photos that you take, whether they're written by hand or typeface. It'll find the text and you can search for it afterwards. Finally, a lot of people have boxes at home with stuff they don't dare throw away, but they just want to forget about it. Before I put anything into those boxes, I have those boxes like anybody else. Before I put anything into those boxes, I'll take a photo and put it into Evernote so that I can just quickly scan through the corresponding tag in Evernote and find all that stuff, those little bits of plastic or whatever it is, without having to open the box. So that's Evernote. Before I started to build a client for Evernote, I had some questions for myself. Obviously, what should I build? And what should run on the phone? What should run on the watch? And I guess the fundamental question is, why would anybody use the watch for Evernote, as opposed to pulling out a phone and looking at the phone? And for any application, indeed, why would anybody bother using the watch? So here's a demonstration of what I created on the Evernote client. And I don't think I got it right this first time, but I learned some lessons along the way. Okay, here's a quick demonstration of the Evernote client. So the top level menu is a fixed menu. It's got all the items you'd expect from pretty much any Evernote client. If I go to my notebooks, for example, I can see my list of notebooks here. If I go into unfiled, then I see the notes that are in the unfiled notebook. If I go to notes, then I'll see all the notes that I have. Sometimes it takes a little while for the notes to catch up. If I'm scrolling down, although it's keeping up pretty well. Same with, for example, shortcuts. These are my shortcuts that I have. Just a couple of shortcuts there. Okay, so that's the Evernote client. It's pretty full featured, at least for viewing, shall we say. So some of the constraints I had when I created this client was that the watch, as I mentioned before, can't really work standalone. It doesn't have a direct access to the internet. So although Evernote does have a C Evernote API or SDK, it wouldn't be possible to use that on the watch to access Evernote directly from the watch. Another thing that was a little bit tricky was that my menu hierarchy was dynamic. For example, when I go to my top level and go to a shortcut, those shortcuts could be anything. They could be notebooks or tags or saved searches, and so the different levels in my hierarchy are essentially dynamic. Coupled with that, we have an essentially unlimited menu size, because you can have thousands of notes. I have around 3,000 notes in Evernote, and with no dynamic memory allocation, you have to think carefully about how you're going to implement that kind of thing. The final constraint that I was faced with, which made it particularly fun, was that there's no debugger for debugging on the Pebble yet, and what logging there is very, very limited. So I got around the constraint of no direct access by using a companion app that I wrote, a tiny little app that sits on the phone, and that phone will go as a go-between between the watch app and the standard Evernote app that's running on Android. So I essentially piggyback off the standard Evernote client. It exposes the data. The standard Evernote client uses standard Android mechanisms to expose lists of notes and so on. So I was able to reuse that. So I didn't have to do any of the hard work of logging into the Evernote service and syncing data. I could just piggyback off the Evernote client. So the watch app talks to the companion app that itself talks to the Evernote app, which itself talks to the Evernote service. In order to deal with the dynamic menu structure, when you click on a menu item on the watch, I go over to the phone and ask it what should I display, and the phone returns back a new menu. So everything's dynamic apart from that top level. When you're scrolling through your 3,000 or so notes, what I do is essentially page in menu items, page in note names dynamically, and keep on caching them for as long as possible. So I read a lot of code to do with buffer management and caching and paging to try and make that work as well as possible, and to keep menu items in memory as long as possible, so that if you go back up a menu, for example, level in the menu, it's not having to fetch items immediately. Maybe there's a chance they're still cached in memory. And because there was no debugger, what I ended up doing was factoring out all the buffer management code, which was the tricky code, into a separate C header file and a separate C implementation file, and then I used those from a normal debugger, in this case Visual Studio. So I created a a dummy main and debugged into those and tested that code as much as I could, just using standard development tools outside of the Pebble environment, just running on my computer. So what have I learned from this experience? There are two kinds of constraints that I was faced with. The first were the technical constraints associated with the lack of malloc, the limited memory size, there's no debugger. Those actually, paradoxically, were kind of fun constraints to have. The whole buffer management thing I did, that was probably the most fun code I wrote in this project. And so when you are faced with constraints like this, your brain automatically starts to find workarounds and try and work out how to get around them. So there's a lot of creativity involved in dealing with the small message size and the lack of memory allocation and so on. And that was actually fun stuff to do. So there are technical constraints, but there are also constraints associated with the experience of using a watch by itself. And I think I went too far with this watch client. I tried to implement all of the things that you can do on a phone, and I would say that if I was to do it again, I would just pick 2 or 3 limited scenarios and focus on those. So I would focus on allowing you to check off checkboxes in checkbox notes. I'd allow you to browse the notes you'd viewed recently on your phone. I'd allow you to see notes you created near to where you are right now. Those kind of things where essentially the overhead associated with pulling out your phone and unlocking it and starting up the Evernote application and browsing to the right data is greater than the overhead of just a couple of clicks on your phone. So that's the kind of scenario. You're shopping and you're checking off items on a checkbox, or you're about to go into a meeting and you just want to remember the name of the person that you're about to meet, so you can just quickly click on your watch and see the recently viewed notes and view that information. So simple scenarios essentially. Okay, that's the end of my presentation. I hope you got something out of it. Feel free to email me, damien@evernote.com, and find out more about me at about.me/dmears. Thank you.